Welcome, everybody. Welcome to the Boulder and Denver Java Users Group. Boulder's going to do something in person, and Chris Bueno will talk about that in a minute. I'm going to continue with our shortened format, and if you don't like it, let us know. But so far, people have appreciated us just getting down to business. We'd like to meet again in person. We're trying to do that for the November meeting, and we'll do a broadcast as well. So if you can't make it in person or don't feel safe, you can watch it from home. If you have a large venue that would accommodate us for having Venkat as a speaker without a lot of extra costs, let us know. Reach out to myself or Matt or go through the meetup group so we can try to figure that out. Email us any topics that you'd like to see. Reach out via the meetup group. Big thank you to IntelliJ, Agile Learner. We do giveaways. Zeddy will handle those drawings. Thanks to Matt Rabel, who is our speaker wrangler, and to Okta for hosting the broadcast through StreamYard and then on YouTube. Thanks to JFrog. There should be a link in the chat. They're doing a giveaway as well. Just click on the link to do that. I'd like to go ahead and bring up Chris Woina from the Boulder Java Users Group with his announcements, and then I'll introduce the speaker.
Hi, everybody, and thank you very much, Greg. This should be a really good talk tonight. Melissa is an O'Reilly author and international speaker. We're fortunate enough that next Monday we'll be meeting at Rule 4 in Boulder. Rule 4 is Outside Magazine's place of the year to work. It'll be a good meetup, catered hot food, beverages, beer, you name it. And it'll be a combined meetup. It'll be Boulder DevOps, Colorado Kubernetes and Cloud Native, and also the Boulder Java Users Group. So it's just off the Foothills Parkway, easy to get to if you have time to come up. And that's it from us. Thanks, Greg.
Thank you, Chris. And obviously go to the Boulder meetup group and you can get details in the location and the address. So tonight's speaker is Melissa McKay, and the topic is, what does a Java developer need to know about DevOps? I'm excited about this, and really it's any developer, right? But I know we're going to talk about Java specifically because at the state of Colorado, we're using Azure DevOps as a way to build and deploy using DevOps tools to various environments and using some different pipelines. And so just really understanding that environment and how to pass variables down and automate it completely is of great interest to me. And so I really hope you guys all enjoy that. So go ahead and let's bring up Melissa and hand it off to you. Thank you so much for doing this tonight. We really appreciate it.
Hey, hi everybody. It is a pleasure to be here. Really excited about this. I am really looking forward to talking about what does a Java developer need to know about DevOps. This is kind of a culmination of some of my personal experiences. We'll talk a lot of high level things that I'll be talking about, like what really matters. I do a lot of speaking on various topics, a lot of DevOps topics in general, and it'll become pretty clear why that is in a moment. But it really matters to me, given, I had to think way back when I first started as a Java developer. This was probably over 20 years ago now, where I was an intern, and, I had learned how to code. I'd learned, Java as a language, but everything that goes on around it, I did not know. That was all stuff that I learned on the job and over time. So this is something that's near and dear to my heart because I think anyone starting out, and certainly anyone that is more advanced in their career, they're going to need to know some of this stuff and some of these concepts. So this is kind of a combination of many of the different talks that I've given. There was 3 that I chose specifically to combine together to share with you tonight. I have a lot to share, so I'll go through some of it pretty quickly, but I think you'll get something out of this tonight, whether you're a beginner or whether you're more advanced. We're going to talk about what really matters when we're talking about DevOps processes and tooling. We'll talk about building and understanding your dev delivery pipelines, why that's important. Managing dependencies, I think, is huge. And as a developer, we really need to focus on that part a lot. Lastly, I'm going to talk about building your artifacts, and we'll get into some details about building containers specifically. I will focus on containers given some of my background, and these are concepts I think are really important for us to know. But these are some techniques that can be applied across all languages as well. So some background on me: I am a developer, have been for many, many years. I did start speaking a few years ago, and I decided to join the developer advocacy team, developer relations team at JFrog. I'm going on my 3rd year. So this was really interesting timing. I really enjoy teaching. I enjoy sharing what I know. I enjoy the public speaking. However, right when I started is when the pandemic happened. So we all needed to stay home, and I got very versed in how to do video editing and how to do online conferences and things like that. There's some pros and cons there. One thing that I enjoy the most is being able to engage with people all across the world at any time, and I still do that today too. I leave room in my schedule for that. Like I said, I'm a developer advocate. I'm also a Java champion. That was something that was an honor I received during the last 3 years, and also a Docker captain. So I try to keep up with the latest and greatest, what's going on with Docker, what's going on with containers. And I have a few talks coming up at various conferences in the future on those subjects. So why are we here today? What is DevOps? Let's start there. And Wikipedia has the best answer. Good enough for me anyway. DevOps is a set of practices that combines software development, dev, and IT operations, ops. It aims to shorten the system's development lifecycle and provide continuous delivery with high software quality. Okay, this is just a long way of saying help developers do better. Help us all as a team, and also other folks that are involved in a project, help us all be more successful. For required reading, I think these are books that were introduced to me many years ago, and I actually should be bringing these out again. I think it's time to reread these and get these concepts, remind myself of a lot of things. But these are the Phoenix Project, the Unicorn Project, and the DevOps Handbook. Really, really exceptional books. The Phoenix Project is written from an executive's perspective, and it's not just an academic book. It's written, it's like a novel. So it's really engaging, it's really fun, and it follows this team's problems that they go through with a particular software delivery, and all of the solutions that they come up with, and how they start to streamline their processes a little bit more. The sequel, the Unicorn Project, is actually from a developer's perspective, and it's also written as a novel, and there's a lot of the same characters that you would recognize from the first book. The last one is more of an instructional manual on how to put DevOps principles into practice. And it talks about principles of flow and principles of feedback and principles of continual learning and experimentation. So like I said, I always recommend these books. I think they should be required reading for anyone that is on a DevOps team. I would be remiss if I didn't advertise my own book here. So JFrog has a raffle available, and there should be a link coming into the comments if there isn't already. And this is a form that you can fill out, put in your email address. I've got 5 of these books. I'll give them out to the first 5 people that get pulled in a raffle, and you'll get contacted by email in order to get this sent to you. This was DevOps Tools for Java Developers. This was a book that some colleagues and I got together and just decided to focus on what was most important in the DevOps processes for developers from a developer's perspective. And I think it's a really good introduction to the entire process. Okay, so this is a slide deck that I often see in corporate decks at JFrog. It is a pretty detailed step-by-step of the software development delivery life cycle. And it is really, really busy, but I like it because it does a really good job of highlighting how overwhelming DevOps can be when presented with all of the stuff in, the ecosystem. This space is huge, and it's really easy to get lost in the mix. This whole process is an attempt to answer the questions: how do I build everything? How do I test everything? And how do I deploy everything? Where do dependencies come from, and how do I keep everything secure? How do I include automation to help increase efficiency and reduce human error? And then, as expected, of course, there's quite a few JFrog products in here that represent handling artifact management and storage and distribution and security scanning on packages. But this setup has really strong integrations with other components and frameworks out there that you're likely already familiar with and use today. These are all the various build and dependency managers like Maven and NPM, Gradle, continuous delivery or integration servers like Circle CI and Jenkins, and then, of course, provisioning tools like Chef and Puppet. Now, I don't really expect you to see many of the logos on here. It's pretty tiny, but it just represents just how much there is in this space. What is not represented on this slide is everything that happens after delivery. So a lot of your observations that need to be taking place, being able to monitor everything that's in production and in your systems, and be able to provide feedback of how your service or application is being used. All of that needs to feed back into the beginning of the whole life cycle for developers to continually maintain and add features, etc. Now, another thing that this slide really brings attention to is how much is in our wheelhouse, like how much a developer really needs to know. And this is something that comes up all of the time with DevOps in particular. I think there are good and wrong ways to have a DevOps team or to organize a DevOps team. And for me, the whole advantage is to be able to utilize other people's expertise. I mean, this is why we have teams that work together closely. There is not and should not be an expectation that one person, specifically a developer, needs to know all of this in great detail. I think it is very important to have an awareness across the board of what's available, the purpose of certain tools and things like that. But to take a developer off their task of their craft and to put them, on other stuff, I mean, it really can be a full-time job. So I don't think that that's the best use of resources. As a developer, keep that expertise, but on your DevOps team, you should also have folks that have operations expertise as well. So when you have concerns with deployment, there are specific people that deal with deployment. When you have, a bug that needs to be fixed, code needs to be checked in, that's in a developer's purview. So that previous slide can be simplified a little bit. I was on a panel discussion not too long ago, and a question came up about the state of DevOps today and what might be coming down the line in the future. If you compare like existing DevOps tools that are out there and components to car manufacturing, we're still very early in development on these things. And what I mean when I say that is how many of us would be driving cars today if we had to build them ourselves? And sometimes that's how it feels. When you're building a full pipeline from beginning to end, it feels like you're having to cobble together a lot of stuff on your own. We're still putting most of these pieces together ourselves. There's a ton of levers to pull. But for a car, for example, we have a general idea of how to make certain components, how to categorize them so they're easily interchangeable when you go get your car repaired, for example. In software, we're still in the process of working out where the boundaries are on some of these tools that we use, how to make these components that make sense. But we have a pretty good idea of what we need to know now to get everything up and running. And generally, tools will fall into these core components or categories. We can simplify this a bit, break down all these things we just saw in the previous busy slide into these core components. And that includes your source code repository, That's your single source of truth for all of your devs. Continuous integration, being able to build and test on every system that you have out there. Your package managers, this will provide you a full bill of materials so that you understand clearly what's in your package, what's in your artifacts that you're producing. And security scanning, this has become more and more important in recent years. These are deep scanning of dependencies and containers too, if you happen to be using those. And then continuous deployment, being able to deploy, out to the edge at any time, being able to update quickly, and then also being able to deploy to any environment as needed. So before you jump in, before you start implementing a bunch of new processes or a bunch of new tools, picking up all these things and trying to use them all at once, get together as a team and determine what your values are. What are your goals? What do you really care about? And every project is going to be different. There is usually a driving factor that will help you to figure out what to prioritize. And this is where communication between teams comes into play as well. If your team is prioritizing something completely different than another stakeholder, you're undoubtedly going to experience some friction and frustration. And the best self-help guidance out there applies to development teams as well. You need to define what success looks like. It can't always just be this vague, let's do better. We need to have a definition of what that looks like so that you can set yourself up for success and know when you are successful. Your team's values and priorities are going to be different than everyone else's. You're going to have a different set of skill sets. There's really no one size that fits all solution. Tonight, I'm not going to tell you use one tool over another. That's just not how it works. Prescribing a particular tool set to your team would be akin to telling everyone to, wear a uniform every day, size 10. It just doesn't really make sense. And you'll never see me get into an argument about languages either. I don't, especially when it comes to building like cloud native applications and things like that. Sometimes it comes down to what is the experience set that your team has to work with. Sometimes you need to go with that. Change can also be expensive. So choose those changes that will advance your team to that measure of success that you have defined. This picture that I have in this slide is actually my car. And I put this picture in here because I wanted it to remind us to know what is good enough. This car is super old. I've had it for years and years and years. I'm just waiting for the doors to fall off. And but it's not something I'm going to spend a lot of money on in repair. So a few years ago, I got into a little accident, and you can tell that there's a little wound on the side of the car. Well, that was a $12 purchase on Amazon to buy a magnetic Band-Aid and put it on there and, just go with that. I'm not going to spend my resources to fix that on this particular car. Sadly, there's some software that's like that too. So you really need to know what, not just the goals of your team, but all of the stakeholders involved. There's always money involved. There's time and resources involved. So all of those things will come into play when you make your decisions on how you build your pipelines and where you spend your time. There are two really important aspects of DevOps, and that is inter-team communication and intra-team communication. In a DevOps world, observability of your system is going to become extremely important, and that's often, it could be a completely different team than you. And I put this slide in here just to remind me to tell you another interesting story. And this is a real life story about a disconnect that my team at the time had regarding a specific business value that we were unaware of. And most devs have seen a line like this before in their code base. I'm not going to argue whether this should be there. This is what we had. And I was actually working on an efficiency issue in the code base. And I was very proud of myself. I implemented a really clever fix It involved changing this log statement, though, because this log statement was no longer applicable for the very simple reason that the function itself was no longer named transform media, for example, and it just didn't make sense anymore. Unbeknownst to me, this little minor change caused a huge fuss. And at the time, I was working in an open space, but there were a lot of product and business and marketing people that were on another floor in the building. Our floor had the better coffee. So those folks would always be down in our kitchen drinking the coffee. And I just happened to overhear a conversation between them saying, well, this particular tool is not being used very much anymore. I think we should discontinue it, or find something else that will work better. That kind of thing. Well, my ears perked up because when they named the particular product, I knew exactly what they were talking about, and I was really interested in why. Why would they make this decision? And apparently, they had some dashboards out there that I think they were Splunk dashboards, and they were utilizing log statements such as this in order to populate that information. Well, obviously, since this log statement had changed, it was no longer populating what it should be. So right away, we had a disconnect. They had a particular priority and a particular value system that they were moving forward with, and we did as well. We wanted quality of code. We wanted it to be more efficient, but we weren't talking to each other about the goals of the product and the business value of the product. So we were, not in lockstep. We missed that. So thankfully, I was able to overhear that, and we were able to rectify that situation. But that's just one interesting thing that can happen if you don't have that intra-team communication. So if you only get one thing out of this talk today, it's this: avoid silos. And I'm not talking about just between members of a team where, maybe a dev goes off in a corner when puts headphones on. That's not what I'm talking about. I'm talking about between teams. Make sure that you have an understanding of what the goals of the project are and what the values are. If everyone is pulling in different directions, you're going to end up stepping on each other, much like what happened in my log story. And when your team decides to charge a hill, make sure that everyone involved in that effort is charging the same hill, that you're all moving in the same direction. This means that communication about business goals needs to flow between all stakeholders, from the business and product level to the engineering and development teams. You'll find there is a lot of focus on the end result when we talk about, putting pipelines together and stuff. Your service or application that's running in production right now, what is the end result? But something you'll realize with experience is that your end result is going to depend a lot on everything that happens before. Think about your software development lifecycle itself as a product. Consider the processes that you take to get your product to production. Find the waste. What is slowing everyone down? And part of this is determining your priorities. For your situation, is shortening the time between releases the top priority, or is there need to focus on quality or on security? And something that the DevOps handbook points out is that in the physical manufacturing industry, it's really easy to see bottlenecks. Physically see them. In technology, it takes more effort. We need to implement those methods of making our work more visible. And the best example of this is, use of Kanban or sprint boards to make our activities more visible. Solutions like that will help the team stay organized and aware of what team members are up to. But sometimes we forget that these types of communication are actually meant to help with the communication between teams as well. Keeping this information limited to internal team members defeats half the purpose of boards like this. Now, that's the high level. Another level is, of course, observability tools, alerting, monitoring. All of those things need to happen as well in order to monitor your success, monitor your progress. But consider putting some of those tools to work, not just on your end product and production, but maybe along the way as well. Collect some metrics, like how long does it take for my application to build? During continuous delivery, is there anything that can be improved there, things like that. All right, let's talk pipelines. Pipelines is not a magical word in DevOps. Everyone has a pipeline, whether it's manual, whether it's automated, whether it's high tech or low tech, it doesn't matter. This word is a bit overused. Many of the products and services out there even use the word pipeline in the name. And I would bet that most of those products that focus on pipelines, they usually imply some sort of automation. That's what's involved in those particular products. It's just that pipeline itself is really the steps, all of the steps that are required to get your code from development to production. And every member of your team should be familiar with your pipeline. If not, stop what you're doing. Get everyone together and document the steps. There might be some surprises in there, maybe some manual things that are happening that only one person knows, or some things that are redundant, or some things that are unsafe. It's definitely something that you need to do is whiteboard this activity. Make sure that it's documented. Too often do I see documentation that explains how something is implemented and forgets to explain why. And the problem with that is you end up with, members of your team who want to make radical changes. But if there's no reason why, you could end up in this circle where a change is made, everyone's, happy for a while, and then you end up changing it back. I mean, the reality is that, people move, sometimes they move off teams, you get new people on, and you don't want to just keep repeating the same thing over and over. So if you've had a bad experience with a particular method, write about it. Make sure it's included in the documentation. If you changed a component out, let's say you chose to use a different build server, make sure you explain why. That way, when the next person comes along and says, hey, I've always used this previous build server in the past and was successful, let's go ahead and change our project to use that. Then you'll have this documentation to explain why maybe that isn't a good idea, or, at least don't repeat the same mistakes. For each of those steps in your pipeline, look for improvements you can make. This is a continuous activity. Where can you get the biggest bang for your buck? And we talked about making priorities, and as you step through your pipeline, you might adjust your priorities. But having priorities is not enough. Not enough just to say we want to do better. Make sure to document your goals and determine what metrics that you can use to figure out if you've met them and you're successful. Start out small with goals that improve some facet of your pipeline by 1%. An example of a bad goal would be deploy faster. Everyone wants to deploy faster. You need to start with a baseline. Say it takes us this long to deploy. Is there anything we can do to improve that time? Is it worth it? Is there some other place in the pipeline that needs some attention first? This is an excellent time to consider different tools and frameworks that promise to help with your flow when you're considering your priorities and trying to make improvements. But the most important thing that I want to stress is always have a reason for that change. Don't just go switching out technologies without having some metrics behind it that proves worthiness. It is fun to play with new stuff, and there should absolutely be time devoted to that. But implementing new tools across a team needs to have serious thought and consideration behind it. And you need to have buy-in from your teammates on this as well. So one thing I've learned over the years with all of the new promising DevOps frameworks and technologies out there, there is always a cost associated with switching one out for another. We're often guilty of seeing the pros. We get advertised to, and convinced to make changes, but then only after the upheaval of change do we see the cons. You've just signed up for different problems. So I know I've seen that happen on teams a lot, and I have plenty of stories about like switching out different continuous integration servers, that kind of stuff. So be careful. Like I said, it's not, it's not a, if it's not broken, don't fix it. That's not what I'm saying. What I'm saying is time box your exploration. Make sure you always have time dedicated for that, but limit your risk there. If you've got I would limit a percentage of your time, a percentage of your resources for new things, new technologies, new frameworks, things like that. We this there's a reason for this picture. I was on a team once where we used source control, sure, but we didn't really have a good method of verifying our builds first. I mean, it was kind of we trust everyone to run a build first before they check something in and merge the code into the main branch, right? Well, when more and more teams were moving to Git and stuff, I remember moving to like a Git flow type of, method. And it was really enlightening to me, because what would happen to me in the past is you would come in the morning, you'd sit down at your computer, and you want to hold back on pulling the latest code, because what you need to do first is check your email and make sure that the build isn't broken first, and that you don't just pull in broken code, because then you're stuck. You're stuck with that code, unless you want to fiddle with trying to, troubleshoot, having an entire development team. And there were many, I don't know, 50 developers or whatever. Having everyone trying to troubleshoot and figure it out, is kind of a waste of time, right? So if anyone was guilty of doing this, late on a particular work day, and they just want to get something in, and they do it without running a build first on their local machine, they had to bring in donuts the next day for everyone. And depending on how much you value eating donuts, you might not see that as a huge problem right off. I think a lot of us just accepted it as this is how it was. But there is a better way to do that. And this is where you can find a lot of improvements, I think, in your continuous integration system. So have your build server take care of this for you. Have automated builds. Don't merge into the main branch immediately. Be able to have a mechanism so that developers can check something in, but they get notified if it's not going to work with the latest changes that are, available in the code base. It is one more step, but I do really, really appreciate the pull request system, being able to have that, and to be able to have it set up to be notified if there are any issues that need to be fixed first before it gets, merged in. It's all, very helpful. And part of that process too, this was also a symptom of this problem. There were some of us, especially ones that were new, that we just didn't understand how the build worked. In this particular scenario, of course, the build server would do the heavy lifting of a lot of building, but there's a lot of things that you can do as a developer to make yourself more efficient. And one of those is just understanding your build, how every component is built together. Now, in my particular case, we had a mono repo. That's a whole nother discussion. But within that repo, there were various modules in there. And if you were just to do the basic, script to build everything, it took like 30 minutes or something to build. If you're making one change in a module, it would be helpful to know what else is dependent on that module, so that you could be a little more efficient with your time, rather than just running a build every time you make a change. Running a build on the unit test for that module would be really helpful. Then you could, check that code in, open your pull request, and then let the build server handle, the rest of it to make sure there's no compatibility issues with the rest of it. It can save yourself a lot of time. So just that slow process, that's something that you can tackle with your junior devs by teaching them, mentoring them, helping them learn how the build of the product actually works. Not even just juniors, but people that are being onboarded. It's very important for them to understand how all of the components of the project work together. That brings me to avoid skimping on your test and QA environments, especially when it comes to integration testing. I've been on teams before where there just was no test environment. It was kind of like, we test in production. I Don't know how many of you have had that experience, but it can be pretty miserable. If you've got a low budget project or something like that, sometimes that happens, but it's just hardly worth it. And it's expensive, really, it is. It's better to have some kind of test environment where you can really be able to tell if there's any integration issues. It should resemble production as much as possible. Obviously, you're not going to have all of the same resources, but with the containerization resources that we have available to us today, we really have no excuse. One example of this was a particular project I was on, relied on internal in-memory database unit testing to make sure that, everything was functioning correctly with the database. Well, enough of us have worked with different kinds of databases to know that that's not always the most reliable method. And sure would have been nice to have a test environment that spun up a Postgres database, for example, the exact version that we would be using in production to make sure that everything was okay before we let any changes go by. That was an unfortunate upheaval for our team at one point, is realizing that there was a pretty significant portion that just wasn't working correctly just because of a difference in SQL between the in-memory database and what we were using at the time in production. Also, any of the artifacts that you want to deploy, make sure they have gone through the process of Q&A and test via promotion of the exact same build rather than rebuilding for a particular environment or for the release. If your environments require different configuration, this should not equate to a completely different build artifact. That kind of defeats the purpose, right? Because you've tested something, but now you're going to build something else to put in production. Your build should happen once. And as that build goes through the stages, it should be that artifact that backs that build should be promoted. Any configuration and stuff that is different between certain environments, that really shouldn't be hard-coded within the project anyway. It needs to be managed outside of the build artifact, either through flags on launch, for example, or config files, that kind of thing, to make that a little bit more resilient. Then we get to deployment. Humans are horrible at repeated tasks. We get bored, we get complacent, we always miss something. I was on a project once where there was a certain deployment, and none of us, we were just now, learning this is a brand new project. It was being brought in from a third-party contractor. It was being brought in internal for our team to maintain and stuff. And we were unclear on how it was being deployed. And it turned out that there were some scripts that were written, and these scripts were, I say multiple scripts in multiple different places and multiple different versions of these scripts. So obviously not the best way to be going about deploying something reliably and repeatably every time. And even more important is, we didn't really have a good way of rolling something back to a previous deployment. And prior to moving to a DevOps team, I did not really know how stuff was deployed. I just kind of, I did my job, I committed my code, and I was done. I wasn't really involved in deployment so much. But after learning how that worked, at least for this particular project, I realized how much I didn't appreciate the trouble that they were going through. Just like knowing your build deeply, know how your deploy works as well. List out exactly what it takes to deploy and whiteboard those steps if necessary. And most importantly, automate what makes sense. And you can do that in pieces. Remember that 1% idea? This isn't something, it's not all or nothing. So do your best, find the places that you can automate and get that done, and you will continuously improve. So let's recap just that section. Understand your project's business values and goals. That means eliminating those silos, getting rid of those communication problems, document your flow and pipeline. You may be surprised by some things there, and this will be invaluable for when devs move on and off your project. Prioritize and improve by 1%. Don't get yourself overwhelmed trying to fix everything. Likely you will solve or improve one bottleneck to discover another, and you need to move your priorities at that point. Make your work and your metrics for success visible, and that just means setting yourself up for success by measuring a baseline before you make changes and set up realistic expectations for the outcome. And this will help you with prioritization if you realize during that exercise that a desired change turns out to have an undesirable cost to benefit ratio that doesn't match up with your project goals. And then master your CI/CD, your source control management, your testing, your artifact management, and your deployment. Know the details of your build, where your artifacts are coming from, and how things are being tested and deployed. And then, of course, automate where it makes sense. Don't just automate for automation's sake. Automate what is going to give you the most bang for your buck. And obviously, this is going to depend on your priorities, your definition of success for the project. But you might find that automating only a portion of your workflow is all that's necessary to meet or even exceed your goals at that point. And you can move on to more fun stuff, new feature, perhaps. Okay, we're going to take a short break here, and I'm going to just talk a little bit about Rube Goldberg machines because I like them very much. I think they're cute. They're fun. This is a pretty easy internet search. These are very popular, but for anyone that is not familiar, a Rube Goldberg machine is a ridiculously complex and inefficient machine. Usually it's composed of a high number of moving parts, and it sets out to achieve one specific goal. And Rube Goldberg, the person, was a Pulitzer Prize-winning inventor. He was a cartoonist, and he made these machines popular through the cartoons that he drew. That was something that was new. I didn't realize that. The one shown here is called the self-operating napkin, and you can see all of the necessary steps labeled. Obviously, this isn't a real-life Rube Goldberg machine. We'll see a couple of examples of those in a minute. But another interesting fact about Rube Goldberg is that he is the only person whose name is in the Merriam-Webster dictionary as an adjective. So thought that was pretty clever. Another thing I was able to find out is there's actually a contest held every year for participants to create these. You can go to rubegoldberg.org to find out more about that. And each year has a theme. This last year was the focus was on literacy, and the challenge was to create a machine that would open a book. And you can find videos of the top 10 selections of the machines that were built. They're super cute. There's a lot of very clever kids out there that are creating these. So this is fun, but where am I going with this? And this is what I'm talking about. We talked about goals for your software delivery lifecycle. I'm going to make the argument that actually putting it together and implementing a pipeline is like a Rube Goldberg machine. But I want to expand a little bit more on that analogy. And there's 3 characteristics that I think of when I make that comparison. There's a lot of moving parts. There's inefficiencies. And there's a tendency to be unreliable and unsafe. So this book that I was involved in writing, I empathize wholeheartedly that software development and delivery is not an easy problem to solve, especially if you're new to today's landscape, if you're involved in cloud native applications, all of those components and tool chains that could be potentially involved in your delivery pipelines became very apparent to me during writing this book. This was published earlier this year, DevOps Tools for Java Developers. And my co-authors and I came together with this intent of gathering for readers much of the knowledge and background that's required in order to develop and deliver software efficiently and safely. These are a lot of the topics that we discussed in the book. And this material gives you a really good idea of what you're getting into and what It'll undoubtedly result in you wanting to take a deeper dive on many of these subjects in order to develop a solid development and delivery pipeline. We did discuss some of the most common tools used in the industry, and we even touched a bit on Kubernetes here. But what becomes abundantly clear is that the entire process can be overwhelming, significantly more so in a cloud-native environment. I did a quick search for the largest Rube Goldberg machine, and it turns out there was a video posted on December 10th, 2021, last year. This whole machine takes 4 minutes and 26 seconds to run. You can see how happy they are at the end. That's how I felt after getting my first pipeline successfully deployed. This made it to the Guinness Book of World Records, and it had 427 steps involved. Many of you have probably seen this already. This is the CNCF Cloud Native Landscape Map. This is from the Cloud Native Computing Foundation, which is under the Linux Foundation. And I don't expect you to be able to see a lot of the logos here. It is massive, but it's just to highlight one of these smaller sections labeled orchestration and management. There are 20 items that are categorized under scheduling and orchestration tools and frameworks. There's 7 under coordination and service discovery. There's 10 under remote procedure call. There's 21 under service proxy. That's where you'd find something familiar like Nginx. 19 under API gateway. I thought that was interesting. And then there's another 17 under service mesh. And I love jigsaw puzzles. That landscape became a meme, and an earlier version of it made the rounds on Twitter a couple years ago as a 1,000-piece jigsaw puzzle. I was thrilled when I went searching for this, and it was an actual thing available on Etsy, but apparently after selling 42 of them, it's now sold out. If it ever comes back, I might consider getting it. I like jigsaw puzzles enough. So I've made the case for a lot of moving parts, but the fact that there is a lot of moving parts, that's not necessarily a bad thing in and of itself. But what you choose to use for your particular use case and how you use them, that can lead to a measure of inefficiency, which is the next part. If you're new to this landscape, it's going to take you a while to find your place. This is reasonable to expect. It will take the expertise of the entire team from development to operations. Although some have been involved across the board from beginning to end, it's usually expected to take some years of experience to be able to do that. It's a tall order to ask one person to know everything. And we discussed that at the very beginning of this talk, that's just not efficient to have one person know everything, or be expected to anyway. This is something that you have to grow over time with to add these things to your toolbox. This is one of the misconceptions about the whole DevOps methodology that I come across all the time. Putting that responsibility on everyone, having developers know everything about ops and vice versa, just doesn't work out very well. Just know that you will make mistakes, but the important part is to learn and continuously evaluate your solutions as you go. This Rube Goldberg machine dates me a little bit. I actually remember using a typewriter. I also remember running out of the white correction tape that you'd have to load into the typewriter. This one uses a drill to press on the space bar, but it reminds me of something really specific with software delivery pipelines, and it's one of the more interesting phenomena that I encounter most. It's that software tools can be used in ways that were unanticipated, and often in ways that are unintended by the creators and the designers. And this can be to a number of different factors. The first, just a lack of due diligence when evaluating a tool for use, or simply an attachment to a tool, a desire to make it be a one-stop shop, make it work for everything. Development of a pipeline that's ad hoc, that implies a lack of planning or agreement on what actions are required and where. This can actually lead to several different tools being used that overlap, that are redundant. Perhaps the unavailability of a feature that you want. Either the team doesn't know where to look, or they aren't allowed to use available solutions because of licensing or other corporate restrictions. That can happen. And those are all common reasons, but regardless of why, this can cause an assortment of issues. And one is that you end up with glue code that can be a maintenance nightmare. An example of that, of glue code, is that it provides some kind of compatibility between two different tools that might make sense at the time, but then all you need is one of those tools to be updated, and then either the tool, it could happen to either side, and then your glue code is broken. That's a maintenance nightmare. Another is that projects or tools that originally had a specific focus, they start to become spaghetti code, unmanageable, and bloated. Sometimes this can just be the result of an attempt to respond to community requests for features that are really outside of their focus. And it may be that a different tool altogether would be better suited for those requests. And there's a lot to unpack there, especially when it comes to meeting the needs of the community and open source projects. That's always a challenge, to push back on things that completely make sense for a specific use case, but maybe it doesn't make sense for that particular project as a whole. So all of those things I listed, those can lead to some pretty severe inefficiencies in your pipelines. This brings me back to the little shell scripts that I found scattered all over the place that were meant to deploy a particular product in the past. Okay, there's one left. This one is actually pretty serious when it comes to pipelines. And I'll go more into detail on that, especially as it pertains to containers. Remember this slide, bringing it up again. And again, this doesn't even address what happens after deployment. This is all just up to deployment. But even if you've managed to cobble your system together with all of these different parts, there's likely points that include that glue code I was speaking about earlier that handles various integrations between different tools. And this can lead to a measure of unreliability. We discussed that. As a developer, there's a phrase I've heard often, and it was called happy path coding or happy path programming, meaning that you don't consider all of the bad scenarios, you just get it working and get your happy path done. Not always the best way to work. And just like with happy path coding, you can easily end up with a happy path pipeline where everything needs to behave just like a Rube Goldberg machine in order for a successful end result. Reliable pipelines, more often than not, come from a lot of trial and error. And much like I imagine that, Rube Goldberg machine we looked at earlier, that would take a lot of time too. In fact, the team on that machine said it took 3 months to build that machine. Glue code or not, everywhere on this slide where you see one of those green connecting lines, those are places to start looking for weaknesses and putting some serious thought into what to do when there's a break in one of those connections. Is the result that the entire pipeline breaks down, or are there some measures that you should be taking to handle paths that are not happy paths? There's clearly a ton involved in putting a full pipeline together. I'd be remiss if I didn't mention those parts that are terribly unsafe if not addressed. This diagram comes from the Salsa website that stands for the Supply Chain Levels for Software Artifacts, Salsa. It is a security framework, and it's basically a checklist of standards and controls that you can use to improve integrity, secure your artifacts and packages, and your infrastructure in your projects. It's a good explanation of how you get from safe enough to being, in a better state at any link in those chains. So any of those weak points. Between your source code and delivery of your product or deployment of your service, there's places you need to take extra care to protect your supply chain. And that is indicated by each of these red triangles. Those are opportunities for disruption. And as a developer, I focus on the ones that are around the build process, even around the continuous integration build processes. In a lot of the talks that I do, I focus a lot on dependencies. In particular, that is definitely in a developer's realm, so it makes sense. All of these pieces and parts of libraries and other artifacts that your code depends on, this aspect becomes even more important when using containers. And one of the most crucial areas to harden is your build process during continuous integration. You must ensure that the dependencies that you're pulling in are exactly what you expect them to be. For example, they need to have an expected version, which means you need to specify a version. You also need to verify that you're using a trusted dependency and not a malicious package that happens to have a similar name, for example. Now, as Java developers, we're a little spoiled here because I know there definitely have been some problems. One jumps to mind immediately for Java developers, but we at least are protected a little bit with Maven Central, like when we use Maven for, to pull in our dependencies. At the very least, these have to abide by a namespace. An owner of that namespace maintains it. When you get into other artifacts like Python or JavaScript, if you're using NPM, it gets a little more tricky, because anyone can name a package anything, and as long as that name is available, they can just throw it out there, to NPM and to, so that it's accessible by PyPy and all of that. These are big problems, and it has come to the forefront. There's a lot of vulnerabilities that have been discovered out there that have to do with that type of behavior. So managing these dependencies responsibly, a lot of this is just understanding your build and where these dependencies come in. Since using a Docker file is pretty common, let's start there. Talk a little bit about a Docker file. This is an overused graphic, I know, but that concept is out there, that software is potentially made up of a ton of components that a developer doesn't necessarily have firsthand knowledge of. That cannot be understated. Applications and services today are more complex than ever. Developers generally don't want to recreate the wheel if it isn't necessary. They want to continuously put out new stuff. This means reusing a lot of, libraries, and maybe open source libraries, or libraries even just from other internal teams. It makes a lot of sense to be able to do that. Containers especially are an issue. Container images. When I started working with container images, I was pretty naive in the beginning. I just, wanted it to work. I learned enough about Docker to get my images built, and then started, pushing them out there to see how they run. But the more and more I looked into it, the more I realized how much you can shoot yourself in the foot if you aren't careful. And this is just a simple contrived Docker file, and there's several problems in here. I'm not going to go over each one because there's more details I'll go over later, but there's a few. So, obviously that first line, from untrusted parent image. Well, what does that mean? Well, a lot of these, Docker files, images can be built based on another image, on a parent image. There's that hierarchy there. And if you don't know where your parent image is coming from, how do you know what's going to end up in your container when it gets launched in production? These are things that you have control over. There's no tag here. This is just the name of an image. There's no, version associated with it. Even if there was, images have this crazy, unreliable tagging mechanism that can be overwritten at any time. Your processes can help with this, of course, but the reality is it's very easy to override an image tag with a completely different binary. They're just pointers. So you might want to consider using a SHA or something. Lines 2 through 4, again, not specifying versions. Apparently, whatever the base image had, there's still some OS packages and stuff that were needed. And, I often see lines like this in Docker files. But if you ever need to build this image again, you're going to run into some you could potentially run into some troubleshooting problems because any of these packages could be updated. They could be updated in an incompatible way, and then you're just going to have to chase that down. Line 6, that could be a problem. Basically, you're copying everything. You're not being real specific about what gets copied from, your working directory or from the directory that you're building from, what gets passed to the Docker daemon. You can get a lot of stuff in your final product that you don't want. I'll show you some more details on that in a bit. Number 7, line 7, there's an external resource there that you don't have control over. We'll talk about that more in a little bit as well. And then finally, number 9, there's no user or group assigned. So this just runs as root. This little start script here just runs as root. These are just a few problems that I come across frequently in Docker files. It's a really good place to start. But all in all, this proves my point. Software delivery pipelines are definitely a little bit like Rube Goldberg machines. So you're probably wondering if there's any real solutions to these problems. Let's talk about that a little bit here. There are a ton of tools out there that will help you with the real case scenarios. As overwhelming as it is, that CNCF landscape, for example, at least list tools within categories that will be helpful to you. If you're just starting out, if you just have to pick one. For now, quite a bit of research is required to vet and evaluate those solutions, but we see how important that is. So make sure that you do that. The hardest part is just getting all of these pieces to fit. And the industry right now is ripe for real holistic solutions that solve the basic problems of continuously delivering and updating software, as well as monitoring and troubleshooting in production. Simple to say, but there are a lot of one-off tools out there that have grown out of very specific engineering problems. And what we really need right now is agreement in the industry on what best practices are, so that we can wrangle some of these tools in. Organizations are coming together to work on these issues. One important effort that was started is between JFrog and Nginx. F5 and Nginx, they have this open source project. It's called the MARA project that they've been working on. It's an acronym for Modern Application Reference Architecture. And it was announced last year at their conference, Sprint 2.0. It's basically a framework for deploying any containerized application in a reliable and repeatable way. And I've taken a look at it, and there's definitely some things that we want to work on and improve and make more interchangeable, a little more abstract to be used for different types of circumstances. But this is just one example of organizations we're working together on this one with that intention of producing open source, at least, that will be available to everyone in order to push forward best practices. There's also an effort with the CD Foundation. This is a sister organization to the CNCF. It is also underneath the Linux Foundation. They are working on determining and defining best practices at this higher level at every business interest, every stakeholder interest, in order to define why we're doing what we're doing, in order to help guide and direct some of the efforts that are happening on the engineering side of things. This is the landscape map for the CD Foundation, the Continuous Delivery Foundation. It has a number of different associated tools, but it's not quite as overwhelming as the CNCF. It has more of a limited focus on continuous delivery explicitly. And they, are really working hard on discovering things or ways to make tools more interoperable rather than strongly integrated. That's avoiding those glue code scenarios we talked about earlier. And of course, outlining best practices. And there's a number of organizations that are involved in the CD Foundation. All of these meetings that they have, especially with the special interest groups, they're open to the public. If you were to go to the CD Foundation website, they have a public calendar. You can definitely attend any of these meetings. I'm a co-chair of the Interoperability Special Interest Group, and we often have these projects come and present to us, explain to us why they exist, what benefits do they offer, that kind of stuff. And that way, we learn more as a group, and we publicize projects that we find very valuable. A couple of examples of projects that have come out of these efforts. This one, CD Events, actually originated in the interoperability group. This one, basically, it is a, defining a way for all of the products to submit and to read events from other tools in a common format. If any of you have worked with cloud events, that's a very similar thing, and that's really what this was based on, was cloud events to start, is just defining what that means so that we have this common place and can avoid the glue code scenarios. Another project that came in recently is Parsia. This one is actually backed by JFrog, but it is an open source project, and it has to do with decentralizing package registries, making sure that where possible, if there's access to source, that it can be verified between a few different nodes, that taking that source and building it ends up with the same artifact. This gives you a little, more security, knowing that you're getting what you asked for, that the artifact that you've requested hasn't been manipulated in between, the request and when you receive it. So we are developers. We do need to talk more about dependencies. Not just security issues are involved here. There's a lot of efficiency issues as well. And again, I'm going to chat, bring in this slide, all of these places where we end up dealing with dependencies. This is not reserved for just operations to worry about. It is part of our build process. An integral part of our build process is to be able to pull in the dependencies that we need. And then knowing how something is going to be deployed later, that's going to affect the decisions of your developers, way back at the design stage and how they create these artifacts to begin with. This is a simplified version of the pipeline, beginning from development, going through CI, going through testing, release process, and then deployment. Where is it in this whole process should we be concerned about dependencies? Well, pretty much everywhere. I mean, this is where we live. Developers are constantly going to be bringing these in and onto their local machines. So they need to know where these dependencies are coming from. In the build server, we also need to know where these dependencies are coming from. Are they coming out from the Wild West, from some public repos, or do we have some control over where they're coming from? Same for testing. This is when we retrieve our artifacts that we've created in the previous steps. So we care where the artifacts are coming from. Is that location, has that been protected? And is that a trusted location? And then for release, we need to be able to promote particular artifacts that have passed certain quality gates as they're moving through the stages of the pipeline. And then ultimately deployment, super important that what we're deploying on our production machines is what we expect. One thing I've seen happen in the past is maybe not enough concern given to permissions when it comes to automation for deployment. And what I've seen happen is accidents happen, not necessarily on purpose, where test artifacts were deployed on production by accident. That could be protected, that could be prevented by protecting your production, making sure that your production machines only have access to production resources. So that whole idea of promoting as quality gates are passed and guarding those locations carefully. That can really help you out there. Okay, I want to talk more about images, creating container images. This is something that is becoming more and more important. Even as a Java developer, even if you're not containerizing your Java applications, you're likely going to be soon, if not Java, some other language. So I think this is really important to get a jump on if you have not done anything with containers in the past. Obviously, there's a ton of documentation. Docker has a really good documentation. I'd advise starting there. Obviously, you don't have to use Docker. There are other tools out there, but this is a good place to start recognizing where there could be problems, where you can make improvements. There's 10 of these. I'm going to whip through these really fast. The .docker ignore file, I did not know that it existed when I first started using containers. What annoyed me the most about one particular project was how long it took to build an image. Every time I made just a tiny change, it seemed like it took forever to build. And that was because I did not understand how the Docker context worked. This is another contrived example, but that line number 3 is the problematic line that we saw earlier in the Docker file. That is copying everything into the working directory. And let's be clear on what's actually happening there. When you run a Docker build command to build an image using that Docker file, everything in that current directory is sent to the Docker context in order to make it available to run all of the commands that are in the Docker file. Everything is then copied into the image. The Docker ignore file is very much like the git ignore file. You can use it to avoid adding any test or user-specific files or even secrets that you might have stored locally. And also consider that .git directory. That's probably not something that you want to be putting in a production image. So at first I thought I could just improve my build time by, I'm not going to copy everything. I'm just going to explicitly say what I want to copy. But in reality, that doesn't help enough because this is what's happening in the background. Again, everything is being sent over to the Docker daemon. That takes some time. And then the Docker daemon determines, you only want these 2 files copied. Okay, I'll just take those over. So the Docker ignore file helps you out with that very first step there. It only sends over what's needed. It can save you some time. So this is an example of what one looks like. You can avoid adding README files that you don't need, passwords, of course, the .git directory, log files, temp files, test files, all these things that will just make a production image a little more bulky. Next one is using untrusted base images. We talked a little bit already about this. I just didn't realize back when I started how base images worked until our build broke one day with an error message saying that the base image didn't exist. Well, it turned out the base image in our Docker file was actually getting pulled from a private repo of the original third-party contractor, which was out of the picture for like a year by then. So, there was no expectation that they would always keep that up. So again, make sure you know where your dependencies like this, where they're coming from. Make sure you bring them in internally somewhere so that you have control over them. This is another problematic base image. Obviously, you're not going to pick something named evil image. But my point here is just to pay attention where they're coming from. These are dependencies, just like anything else. They should be pulled into Artifactory or some other artifact management tool that you use and managed along with all of the other binaries that you rely on for your build. Using Docker official images is a good idea. Docker has a dedicated team that's responsible for reviewing those. They are open. You can see exactly what's in those and see how they're being built. They are, make sure that they are updated regularly, that they work in collaboration with upstream software maintainers and security experts in the broader Docker community. So those are good to start with, but always do your due diligence and make sure you know what is in your base images. Also, are they coming from a private or a public registry? By default, if you don't say a registry, if you don't indicate a registry, they're going to come from Docker Hub. So you might consider, caching them in a private registry that you have control over. What to use. I remember just when I was first starting and just trying to make a little container with some Java application running in it, I didn't really know where to start. There's all these names out there. If you're a Linux person, you're going to figure this out. And it isn't, magic. It's not all unclear. You're going to see names like that in other images besides like Java images or OpenJDK images as well. But there's no mystery in here when you understand what they indicate. You can narrow your choices down by the Java version that you want. If you need to install additional packages, you might want to pay attention to the Linux version that you're using. And then I put some notes in here about Alpine because if you need to look at the documentation when you're pulling these from Docker Hub. So if you go to OpenJDK on Docker Hub, they explained at one point that Alpine images were, they're based off the Alpine Linux project, but they weren't really supported. And according to their documentation, they were only released for early access OpenJDK version releases, and they are not updated after GA. So they're older images that you might not want to use. Now, all of that said, anyone who has gone to OpenJDK and looks at it now, they're deprecated now. So if you're using these images, you might want to go consider, replacing them with something else. If you're already paying for support for a specific distribution, like from Azul, using Zulu images or IBM or something, or you can use the Corretto ones from Amazon, it makes sense to use their official images. So pay attention and make sure that you're updating appropriately. Not defining versions. Not much to say here other than what I just said. Make sure that you define your versions. We talked about this earlier. You really should have a bill of materials for your build. Know the exact version of everything that is installed. And then you can eliminate multiple moving parts when you're building your applications if you control the images. One thing I would suggest, I've heard the reasoning of not defining an image because you always get the latest and greatest and you might as well just run with that. The problem with doing that is it just, like I said, it's too many moving parts. If you want to do things that way, make sure that I would go ahead and explicitly use the versions that you're expecting and dedicate a build where you do just that, because you potentially have a lot of troubleshooting to work out. So make sure that you're not risking getting a feature out or getting a bug fix out just because you're, trying to figure out which dependency got updated and when, and which one is incompatible. We talked a little bit about tags, how unreliable image tags are. Using latest is just asking for it. Like I said, these are pointers. Latest is not always latest. It doesn't always mean what you think it means. It can always be overwritten. It's kind of like using a snapshot, like when you're building your Java application and you're using snapshot images. It's a good enough analogy, I guess. Never updating, of course. We need to update our stuff. Like I said, make sure that you dedicate some time to update things. We know of a specific case where a particular company did not update, even knowing that there was a vulnerability involved, and how embarrassing it was for them when they actually suffered the consequences of that. So block out time during every development cycle to spend on this kind of maintenance. So here's an example. Make sure that you update your base images as well. Keep those current, just like we talked about with OpenJDK. Including build tools. When I first started out with Java and building containers and stuff, I thought, well, how convenient is it just to include one that had Maven already, right? Not have to worry about this. And I see that quite often. It works, but you end up with an image that's quite a bit larger than it needs to be. And what do you need Maven for on a production image? You really don't need all that extra stuff. So it's best also to minimize your attack surface from a security perspective. Just the only thing that goes in your image is what is absolutely necessary to run your application. So one thing to consider is utilizing multi-stage builds. Here's an example of that. You see that there's two from lines in here. That's a feature that Docker added. This way you can choose a very, very slim, minimal base image, and you can just copy, the result of a build into that image. So that's one option for you. Using external resources. Remember in that contrived example we had before, there was a curl statement. I've seen this a lot. I've seen curl, I've seen wget, these kinds of things. It's one thing if this is a resource that you have control over, again, that you update when you want. But I have seen cases and have experienced the case where the result of this statement is nothing because whoever was maintaining it decided to move it, decided to rename it, decided to update it to something incompatible. So rather to be on someone else's schedule like this, it's better to pull in that resource, pull it in so that it's managed internally in your artifact management rather than reach out for it during a build. Trust, but verify, of course. Hard coding secrets, that seems like an honest, obvious one, but I see it a lot unintentionally. One thing I've seen in the past is also this attempt to remove secrets. So as an image is built, layers are added. And this is an attempt to just remove the secrets that weren't wanted in a base image. Well, they're still there though. I mean, just because you can't see them if you were to exec into the image, they still exist. This isn't a good idea. In this case, it would be better to rebuild that base image and make sure that those secrets weren't added to begin with. Also, this is another example of making sure that you make configuration stuff like this port, for example, that you're exposing. Maybe you need a different port for a different environment. So you might want to use a variable instead in this case. That way you don't have to rebuild this image for a particular environment. Just more examples, making sure you don't have secrets and making sure that you're using variables. Doing too much. This is just using these Docker files as like a shell script. Not a good idea. This one's somewhat contrived, again, for simplicity, but it was modeled after an actual Docker file I've worked with in the past. There's some crazy side effects here because think about what happens when a test fails. You really need idempotent operations in a Docker file. Testing like this, if nothing changes in a previous layer, it doesn't get regenerated and rebuilt whenever you're utilizing Docker cache. So in this particular instance, if you're using Docker cache, that cleanup database step is not going to be repeated, but you've already failed a test. So that database is not in a good state for this to ever work. So a better way to do this is keep this testing stuff out. Don't be doing that in a Docker file. Build the image and then have an environment where you can run your integration tests against that image as it is. Yes, so keep it simple. All right, unnecessarily busting cache. This just slows everything down. And when you start pulling apart fat jars, for example, you discover that it is very amenable to you and your time to make sure that stuff that changes frequently is lower in the Docker file than things that don't change as often. So perhaps you might want to consider putting, third-party libraries in a previous step and then copying over, dynamic code or stuff that you are changing frequently that is in active development. Those class files and stuff can come in later. Good to keep your dev builds efficient this way. There's many different ways to build Java images, for example. Whatever method you choose, there's a few out there. You can use like a Maven plugin. You can use build packs. You could use Jib. Understand how it's actually building that image, because things like this will come into play. So again, keep stuff that changes frequently as close to the bottom of your Docker file as possible. All right, lastly is relying on root. I feel bad for repeatedly saying this one over and over and over again. You really shouldn't be doing this. You shouldn't have processes running. I mean, if a process is running as root, it could potentially have access to things it should not on your host. Make sure that you're specifying a group and a user if you're running a process. Pay attention to official images that you pull from Docker Hub, because sometimes there's this, understanding that you're going to be using a user or a group. It's just an issue where the moment, if anyone can get into that container, they immediately have root access. I mean, why make it that easy? So if it must have root access, make sure you have some good reasons for that. Use that principle of least privilege and make the right decisions there. So this is an example of that. This start script obviously is running as root. And here's an example of just adding a group and a user. I think if you were to look like a Postgres Docker file, for example, they're pretty good about this. And there was a report that came out. This was a Sysdig report. And I thought it was interesting that they just did an observation, and 76% of the containers that they observed using Sysdig were running as root, had processes running as root. So I think that everyone's heard this already, but even if that's true, it doesn't appear that we're taking that risk seriously enough. Okay, I prattled on enough about containers. Let's just do a quick summary about what a Java dev should know about DevOps here. You should understand your software development lifecycle goals and objectives. You should know where your dependencies are coming from. That should not be a mystery to you. For example, when you're building on your local machine, are you pulling your dependencies from Maven Central every time, or are you pulling them from a private repository, or where are they coming from? Important to know. Know how your artifacts and your containers are built. Just like we went through understanding how a container image is built with a Docker file, it's important to understand that it has huge effects on your efficiency, how well you're going to be able to get through your pipeline from beginning to end. Pay attention to the risk of vulnerabilities. There are a lot of tools out there right now, and I could show you some if you're interested. JFrog has some really good security tools. There's a JFrog X-Ray does scanning, and there is a plugin for my IDE that I can use, and I can just see right away before I even check my code in. I can add a library to the POM file, for example, or add a package, and it'll tell me if there's any known vulnerabilities with that. So that's pretty cool. Docker Desktop has some good scanning resources as well. And then also, the ability to do that within your pipeline too. Not only should you be doing it at the beginning, but you should also be doing it, as your software goes through the different stages. And then finally, how to plug in and be active in your community. Remember what I told you about the CD Foundation. It's not private stuff going on there. There's a lot of happening things. And get yourself involved. When you choose a new tool, when you're looking and vetting a tool, find out if there's a community resource that you can get involved in. You can ask questions. You can see what other problems other people are having. That will help you with your research and help you with your decision making. And lastly, before I sign off, is just make sure that you go and get your free copy of this book. There's 5 of them available, so go ahead and sign up, and you'll be contacted by email within 3 business days, so we can send you your copy. All right, that is all. Thank you for listening. Feel free to DM me with any questions or comments you have, or if you have any questions today, I've got some time here. We can chat for sure.
All right. And I'm not looking at the comment log, but first of all, thank you so much. I really enjoyed this and got some ideas on sort of what I need to do in my environment with our DevOps pipeline. We use a YAML file and then the pipelines that Azure DevOps have, but we definitely want to try to apply a lot of the stuff that you said for our environment as well. Chris, what'd you think, or do you have any comments?
I thought it was an excellent survey of the millions of different things that you could have brought up. And I thought you did a really nice job of condensing it down to some important high points that people need to investigate further.
Cool.
Thank you very much.
And I'm going to try to pull up that comment log from the YouTube. Hang on a second.
I thought the thing about Splunk was hysterical.
Yeah. Well, it wasn't so funny for me at the time.
Yeah. People build these extraordinarily elaborate dashboards harvesting logs, and meanwhile, we're in there constantly changing the logging and tweaking it or changing levels or changing the messages, not even thinking that it's going to blow up this finicky, brittle thing somewhere
Exactly
in a data warehouse that we know nothing about.
Yeah, our team was not even aware that there were any metrics, that there were any measurements being taken. So we didn't even know to ask.
Yeah, no, that's just beyond classic.
All right. And so the only thing I see is, somebody commenting on the puzzle as a great option. My wife does a lot of puzzles as well. In fact, she has a mat that you can roll it up if you want to pause and then unroll it to continue on. But and then Karina, Carrie Gunther, had some questions about prod data and privacy because of HIPAA rules. We have the same issue at CDOT. We have some data that's law enforcement data that is CGIS is what they call it, and we can't share that. And so we kind of have to set up some test databases and load them up to do testing so that we can not compromise the data and just abide by our security concerns.
Yeah, that is difficult. I've run into that too, especially if you're working with any private data, what is it called? The identifiable data that you're not allowed to work with. Which includes it could include email addresses, obviously credit card information, things like that.
PII.
And there's not a good way to deal with that other than try to duplicate as much as possible in the correct format in order to get the amount of data that you need. But that's something that needs to be developed over time too, as you make changes, add more and more types of data to your test database. One thing I will say about that, that is a hard problem to solve. I don't have an immediate solution for that, but make sure you're protecting your resources between your environments. I don't know if any of you have had that experience where you're like, oh no, it's almost as bad as, deleting a Git repository or something on accident, but it's like you run your tests against prod because you're connected to prod or you accidentally delete the entire test database on accident because you didn't realize, what we were connected to. So these are things that can be prevented if you really pay attention to, permissions that you have to various services.
Yeah, definitely. I mean, for example, for work I do at CDOT, we have the production database shows up in a sort of like a red window, dev is green, and then QA is yellow, so that okay, I know where this is going when I go to do a query or something like that.
That's a great.
I've had a situation where one of our devs, it felt so bad for him, accidentally launched like a message broker, but accidentally connected to production.
Oops.
So he's running tests, and in production, it's like, what's happening to the messages? The messages are just being collected and disappearing, and it was a test environment that was pulling them straight out of production. So yeah,
We just a few
these are
days
all
ago,
funny
we
stories.
just got a suggested meetup, which was a test message.
Yeah.
So the other thing is, one of our attendees commented that they really liked the wonderful images for the context and point you were trying to explain, and they appreciated that.
Oh, cool.
Oh, and there it is. Thank you, Matt. All right. Matt, I know you can't, you're having some technical challenges, but if you want to put in our chat, if there's anything I missed, but I think I got all this stuff. Everybody liked the Rube Goldberg, and I don't know if you ever had this as a kid, but I did, and then we had it for our kids. There's a game called Mousetrap, where you build a Rube Goldberg machine, and the idea to win the game, you have to catch the mouse using this Rube Goldberg setup.
I love it. Yeah.
So, yeah, that's all I got. Thank you so much. I really enjoyed it. I guess I'm going to wrap and let everybody go eat their dinner or do whatever they're doing next. So, thanks so much for coming out. I tweeted some of the stuff that you mentioned. If you could email Zeddy the slide deck, and we'll share it on our meetup site. But I also shared on Twitter some of the links for those tools that you had shared with us.
Oh, awesome. Cool.
So, and
Thanks.
I tagged the Denver Jug, so you guys should be able to see it. All right. Well, thank you, and have a great night. And for everybody at the attend, we'll do this again in October. Our plan is for November to be in person, but please, please, please let us know a venue that we can meet at that can accommodate Vencat, because usually there's a big crowd. Some of the venues we're looking at want to charge like a few $100 for security, which if we can get a sponsor for that, that's great, but we'd rather not spend your money on that, if you will. I'd rather spend it on food for you and drinks and other things like that. So, all right. Thank you, and have a great night.
Good night.